Alright, we're starting with lesson 15.3 over parallelograms. Go ahead and turn to page 213. Our learning targets for today are to develop properties of parallelograms and also prove said properties. So first we're just going to start with a little definition. A parallelogram is a quadrilateral shape with four sides with both pairs of opposite sides that are parallel. Parallel. For the sake of brevity, this symbol can be used for parallelogram. So instead of writing out this long word, we'll just use this as a symbol. Number 1 says, given parallelogram Katy, K-A-T-Y, as shown, A, which angles are consecutive to angle K? Now we've already learned what this word consecutive means. I like to say, so consecutive, or another word maybe next to, if you want to say that. But consecutive, which angles are consecutive to angle K? So go ahead, take a second, pause the video, and see if you can figure out which angles are consecutive to angle K. So hopefully we worked with a partner or with a group, or we were just able to see that both angle A and angle Y are consecutive to angle K. Part B, use what you know about parallel lines to complete the theorem. Well, up here, what is this parallel line? Well, we already said that a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So quickly, I'm just going to notate my image where KY is opposite AT, segment AT, so it means they're parallel. And KA is opposite segment YT, and those are also parallel. So if we use what we know, then we can say that consecutive angles of a parallelogram are what? Take a second, pause the video, see if you can figure it out. Alright, so hopefully we discussed it. Because these lines are parallel, this is basically creating a bunch of transversals, parallel lines cut by transversals. So if we think of KY as a transversal cutting through these two parallel lines, we can see that these consecutive angles are also same side interior angles, and same side interior angles are supplementary. And just like K and Y, if we look over here, K and A are also same side interior angles, which are also supplementary. Therefore, we can say that consecutive angles of a parallelogram are supplementary, meaning they add up to 180. Add them together and they add to equal 180 degrees. Cool. Okay, so for this next part, depending on what you're doing in class, you can use 3 index cards and draw 3 different parallelograms. Then you cut them out and create a parallelogram, and then you want to draw a diagonal and cut along the diagonal to form 2 triangles. Well, I've gone ahead and created a parallelogram over here, and then I'm just going to insert a diagonal. Okay, so this part is where we do a little bit of exploration. So if you do have the materials, then go ahead and pause the video and go ahead and do some of that exploration. But if you don't, I just wanted to show you a little video about taking 2 triangles and seeing if we can create a parallelogram. So if we look right here, I've got 2 congruent triangles, and I'm just going to see what happens and see if I can create a parallelogram. Sure enough, if you look at this, we've just taken our 2 congruent triangles, created a parallelogram, and then this line right here in the middle is a diagonal. So if you had explored with your index cards, then you can see that when we take a diagonal through the middle of a parallelogram, it creates 2 congruent triangles. Just like with what I just did with the video, whereas if we take 2 congruent triangles, we can create a parallelogram with a diagonal right through the middle. So that's just some explorative learning. So if we go back to the book, we can see in number 3, based on the exploration in item 2, we're going to complete the theorem. each diagonal of a parallelogram divides that parallelogram into what? Take a second, see if you can figure it out. Each diagonal actually divides a parallelogram into two congruent triangles. Okay, so number 4. Given parallelogram DIAG as shown above, complete the theorem. A. Opposite sides of a parallelogram are blank. So I found this cool GeoGebra applet online, and we're just going to look at the opposite sides of the parallelogram and see what you can figure out. So if we take this and slide this over, you notice that opposite sides are what? Can you fill in that theorem now? Again, if you want to look at the applet, you'll notice that the opposite sides of a parallelogram are congruent. Very good. Now part B, opposite angles of a parallelogram are what? We're going to use the same sort of applet and look at these opposite angles. Look and see what happens and see if you can fill in the blank. So we're going to slide this over. See that pink angle going across to the opposite angle. Oh, and now this blue one. If you look and see what happens, opposite angles are congruent. Very good. We can go back to our book. Alright, part C says prove the theorem you just completed in part A. So we actually want to prove that opposite sides of a parallelogram are congruent. So we're going to do this in just a simple 2-column proof. I'm going to do off to the side. Here. So we've got our statements and our reasons. So our first statement, we're using this parallelogram up here. So our first statement is going to be the stuff that we know about parallelograms, right? So in these two triangles, we know that segment DI is parallel to segment AG, and that segment IA is parallel to segment GD because of the definition of parallelograms. So now that we've got some parallel lines and this diagonal going across, we can treat it as a transversal, and we know that the alternate interior angles are going to be congruent. So angle DIG is congruent to angle IGA because of the definition of alternate interior angles. And not only do we know that set of angles, we also know these angles as well because they are also alternate interior angles. So we've got angle AIG is congruent to angle DGI because of alternate interior angles definition. So now if we're looking at this, what else do I know? Well, I see this line in the middle where both triangles share segment GI, and because it is shared, we know that segment GI is congruent to itself because of the reflexive property. So we can notate that on our image as well. Now, if you're looking at this, I am seeing a possible postulate to be able to prove that these two triangles are congruent. Can you see angle, side, angle with me? Yep, that's right. So we now have triangle DGI is going to be congruent to to triangle AIG because of angle, side, angle. So now that we've got two congruent triangles, like we learned in the previous unit, corresponding parts of congruent triangles are congruent, or CPCTC, so we can look at the opposite sides of the parallelogram. If they are in fact corresponding, then we know that they are congruent. And would you look at it? DI corresponds with AG, and therefore they are congruent because of CPCTC, as well as segment AI and segment DG. So AI is congruent to segment DG because of CPCTC. And now we have just proven the theorem from part A. Alright, D, prove the theorem you completed in part B. Use the figure in item 3. So I'm going to go ahead and erase this real quick because I don't have quite enough room to draw another proof. So for part D, we're trying to prove that opposite angles of a parallelogram are congruent. And part C actually proves that angle D is congruent to angle A because of corresponding parts of congruent triangles are congruent. Now we just need to prove that angle G is congruent to angle I. So I'm going to get rid of these little notations over here. And I'm actually going to draw another diagonal going the other way so we don't have angle G and angle I obstructed at all. And then basically we're doing the same thing that we did in part C, but now for separate triangles. So I know that DG is parallel to AI and AG is parallel to DI. Because of the definition of parallelogram. I also know that these angles, these alternate interior angles, are congruent. So angle GDA is congruent to angle IAD, and angle IDA is congruent to angle DAG because of the definition of alternate interior angles. And then we've also got our reflexive property again, with DA being congruent to itself because of the reflexive property. And now we have two congruent triangles again. So we've got triangle DGA is congruent to triangle AID because of angle, side, angle. And then, because of CPCTC, we know that angle G is congruent to angle I. And we've just proven using those two proofs that opposite angles of a parallelogram are congruent. So that'll conclude this video. Go ahead and start the other video and we'll start on the next page on question number 6.